welcome to True Projects. In this video, we are going to explain about the project, which is deep learning based YOLO models for the detection of people with disabilities. So before getting into the execution, first let us understand what is the project about. So you have heard right, in the past few years, we have seen a very big leap in the deep learning technologies, specifically when we come to the object detection. So, if you think about computer vision, it is fascinating how we can identify and classify objects in images and videos so accurately. This has made a huge difference in many areas like surveillance, where they need to keep an eye on the things, and medical diagnostics, where quick identification can be crucial, and also monitoring vehicles on the road. What impressive is how reliable and precise these systems have become. One of the standout models in this field is You Only Look Once, that is called as YOLO for short. It has really made a name for itself because it can detect objects rapidly and accurately, even in pretty complex situations. What I found really cool is how YOLO can process everything in real time, which is essential for applications that require instant feedback. It's like having a super sharp pair of eyes that can see everything happening around it and react in the blink of an eye. So, when we talk about challenges in the object detection, when we talk about object detection, there are definitely some challenges, especially when it comes to specialized tasks like identifying individuals with disabilities. So, identifying individuals with disabilities, it is a task. So, when it comes to specialized tasks like identifying individuals with disabilities who has mobility aids, a lot of current methods just don't have the precision or flexibility we need. This can lead to missed detections or inaccuracies, especially when we are looking at real time situations that every second counts. That's really where this project comes into the play. We are focusing on improving how we detect and track differently abled individuals. By doing this, we can provide better, more personalized support through assistive technologies. It is not just about identifying someone, it is about understanding their needs and ensuring they get the help they require. The goal here is to make these systems more effective and reliable so we can truly make a difference in lives of those who are really on their aids. So, to overcome all these challenges in this project, in this proposed system, the main goal is to create a really efficient model that can detect and track individuals with disabilities who use mobility aids like wheelchairs, crutches, etc. So, who use wheelchairs, crutches, etc. So, we are focusing on deep learning techniques. So, in this project, we are specifically focusing on deep learning techniques, especially the YOLO V8 model, because it offers a great balance of accuracy and the speed. And here we want to achieve is to improve what we want to achieve is to improve the way we detect these objects compared to the traditional models like faster RCNN or even earlier versions of the YOLO, which had their limitations. So to make this work even better, we will be using storing strong data sets that includes a wide variety of image featuring different assistive devices. So this diversity will help the model learn to recognize and differentiate between them effectively. Essentially, we are aiming to create a system that not only fast but also reliable, ensuring we can provide the right support to those who are in need. So the main focus of this project is about improving the accessibility and support for the individuals with disabilities. So as an extension of this project, we are further incorporating YOLO V5X6, which is the latest advanced version of the YOLO model, and also the latest version that is YOLO V9. This upgrade really boosts our analysis and also the detection capabilities, allowing us to fine tune how accurately we identify individuals with disabilities and the mobility aids they use. And moreover, we have developed front end using Flask framework to facilitate the user testing. So this is designed to make user testing smooth and accessible. This interface includes authentication features so we can ensure that access is secure. This is really important because we want to create an environment where users feel safe and comfortable while interacting with the system. Moving on to the implementation of the project, we have followed the steps in the flow of work. So, the first step that we have done is we have imported the required packages. This initial step involves loading the necessary libraries and dependencies required for image processing, model building, and training. Coming to the next step, which is exploring the data set. Here, we read the images from our data set to prepare for the processing. And we visualize the images, help us understand the data, and check its quality before further processing. Coming to the next step, that is image processing here, the first step we did is converting to blob object. So this transformation prepares the image for processing by the model, converting it into a format that can be used effectively. The next one we have is defining the class. Here we set up the classes that model will detect, such as different types of mobility aids. Then coming to the defining bounding boxes, this involves specifying the coordinates of the bounding box around the detected object, which helps in detecting, locating them within the image. Then we convert the image into a NumPy array. So this conversion allows us to perform efficient mathematical operations on the image data. Moving on, then next we load the architecture, pre-trained architecture of the model, which defines the process inputs. And then the next step is extracting the output layers. This step involves identifying the layers responsible for producing the final predictions. Then we did some more pre-processing where we have combined the images with their corresponding labels to create a dataset for training. Since OpenCV reads images in the BGR format only, so we have converted them to RGB. So we have images in the only BGR format. We need to convert them to RGB, which is red, green, and blue. And here we have we have created the mask. So this involves generating the binary mask for segmentation, highlighting the areas of interest in the image. And to ensure consistency, we have resized all images to a standard size suitable for the model. And we did basic data augmentation, that is, we have introduced variability by randomly alerting images to make the model more robust against overfitting. Coming to rotating the image, we rotate images to help the model recognize objects from the different angles. And then we did some transformations. This can include flipping and changing brightness and contrast to enrich the dataset. And then we ensure all the necessary packages are installed in the environment, which may involve using package manager like pip. Then we organize the data specifically for the use with the YOLO model, ensuring it meets the model's input requirements. And the next step is building the model. So this step involves setting up the YOLO architecture according to the specifications of the task, defining how layers interact. And we train the model using our dataset, adjusting its weights based on the predictions made and the actual labels, allowing it to learn effectively. Once training is complete, we save the best performing model for future use, ensuring we can deploy it without needing to retrain. And we have developed a user interface using the Flask, which provides an easy way for users to interact with the system, including a registration and login setup backed by an SQLite 3 database. Then in the front end, we have user data. So the front end utilizes the train model to classify and detect disabilities based on user uploaded image. Then the users, they will be giving the images, they will be uploading the images in the front end that will be pre-processed at the back end, that will be feeded with the train model, and finally outcome will be displayed in the front end with their disabilities. Moving on to the algorithms used, these are the algorithms implemented in this project. So these two are the extension models that we have used in the project. Moving on to the requirements. So we have hardware requirements and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hardware of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, and JavaScript. So to implement this project, we need hardware and software requirements. Now let us execute. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. These are the source code files in the code folder of a project. Let us understand each of them. How will they be used in the project? So coming to this sample folder, here we have test cases that we will be using in the front end for detection purpose. Get back. So coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. The next file we have is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have model file which contain the algorithm information. This will be loaded into the project code during runtime of the application. And here we have notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. Now, here in the starting four folders, we have the data set. So let's open the first folder. Here we have two subfolders. One is test and the other one is train. Let us open the train folder. Here we have two more subfolders. One is images and labels. Let us open images first. So here total we have 1261 images. So we will be using these images to train the models that are YOLO models to detect the disabilities in the persons. Get back. Coming to the labels folder, here in this folder we have annotations that are files containing annotations or the labels for the objects in the corresponding images. So here each label file corresponds to an image file in the image folder, providing details about object locations and classes within the image. So for example, the first annotation file corresponds to first image file in the image folder. Similarly, the second image, the annotations for the second image has in this labels folder. So this is the second annotation file for the second image. So similarly, for all the 1100 and 1261 images, we have 1261 annotation files. So let us open one file, for example. Here, this YOLO files, this annotation files, they follow the YOLO format where each line represents the detected object. As there are three objects detected, so here we have three lines. Here we have 0, 4, and 1. Let us understand them detailedly. So each line has object class index. This is the object class index followed by its bounding box coordinates. These are the bounding box coordinates which are normalized to the image dimensions. This is the x limit, this is the y limit, this is the height, and this is the width. So as we have three objects in the image, here we have three lines. 0 is one type of object, 4 is another type of object, and 1 is another type of object. Similarly, we will be having in the all other annotation files. Let's get back. So similarly to the train folder, we will be having also in the test folder where images and labels, we will be using train folder to train the models, test folder to evaluate how the models have performed. Get back. So we also have the same images in the YOLO V7, YOLO V8 and YOLO V9 folders. Each folder they contain the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized, ensuring that each YOLO version receives the correct annotations it needs to function properly. So now copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Here using the command cd followed by the space, paste the copied path and now click on enter. If you observe, current directory is changed to the code folder's path. Now we need to compile the app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform runtime check and syntax errors. I mean, it will check for the syntax errors and logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So now we have to copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to register first. Click on register, enter all the registration details if you are registering newly. I have registered already, so I will directly sign in. So click on sign in, give your username and the password, click on login. We have logged in successfully and we are redirected to detection page of the project. So here you can see a choose file button, right? We need to click on that for uploading the images. Let's click on choose file. So these are the images that we will be using them as the test cases, which are in the sample folder. Let us upload the first image. Click on open. It is loaded now. Upload it. Image will be processed at the back and then we will be getting the prediction. So here we got the three predictions. One is the crutches and the other one is wheelchair, and we also have a person detected. So here we have three detections: a person with the crutches, a person who is in the wheelchair, and also a normal person. And here we have labels for each detection. So for this crutch detection, it is drawn in the red color bounding box with the class label crutches with the 0.93 probability score. It is nothing but it's a confidence level that how accurate the detection is. So it is 93% accurate. And here we have a disabled person who is sitting in the wheelchair with the 8.81%. So here we have class label, and here also we have a person detected. Let's get back. Click on choose file to upload some more. So let us upload this image. Click on open and now upload it. So here if you observe, there are three objects detected. One is the person who is in the wheelchair with the disability, and one who is pushing the wheelchair with 0.80 probability, and the person. Let's upload some more. Click on choose file. So now let's upload this image. Upload it. So here if you observe, there are two objects detected. One is the person with the crutches in the red color bounding box and the person who is walking in the yellow color bounding box. Let's get back. Click on choose file. So let's upload this image. Click on open and now upload it. Here if you observe, there are three detections. Two is crutches and the other one is pushing the wheelchair. So one person is pushing the wheelchair, and here we have the person who is catching the crutch, and here also we have that person who is catching the crutch. Get back. Click on choose file to upload some more. So let's upload this image. Click on open and now upload it. So here we have three detections. One is crutch, person, and the wheelchair detected. So here these are the things, these are the objects detected. Let's upload some more. Click on choose file. So now we will upload this image. So here two persons are detected. One is pushing the wheelchair and the other one is wheelchair. That is a person disabled in the wheelchair. Let us upload last image. So now we will be uploading. So let's upload this image. Click on open and now upload it. Here we have three detections. One is a person and the other one is who is pushing the wheelchair. And here also we have a person with disability who is sitting in the wheelchair. Get back. Now let's check with the graphs. Click on graph. So this is the precision recall curve graph, where on x-axis we have recall rate and here on y-axis we have precision rate. And here we have F1 score graph of YOLO model. Here on x-axis we have confidence level and on y-axis we have FN score. And this is the confusion matrix of the YOLO. And here we have precision comparison graph. This is the precision comparison graph. Here on x-axis we have precision score and on y-axis we have the algorithm names. And here we have recall comparison graph. Here we have MAP comparison graph. So MAP, recall, and precision are the evaluation metrics which are used for evaluating the detection algorithms. So here on x-axis we have mean average precision and on y-axis we have the algorithm names. Now let's click on logout. In this way, YOLO models, they can accurately detect the objects within the image. So here we are specifically detecting the disabled people. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.